Hoffman, and welcome to this Data Exposed exclusive. We are here live at the PASS Data Community Summit in Seattle, Washington, and I'm joined by Brian. Brian, why don't you tell us a little bit about yourself?
Certainly, yeah. So I'm Brian Carrig. In case you can't tell from the accent, I'm originally from Ireland and moved over here about 10 years ago. And one of the things I'm working on, our main area I work on in the SQL Server team, is the data platform space.
Okay.
So then immediately you might be asking, what is data platform?
That was exactly what I was thinking.
So the data platform space is really the kind of things that touch SQL Server or interact with SQL Server without necessarily being integrated into SQL Server. So we're talking things like file systems, operating systems, hardware, storage fabric. These kind of areas are my area of expertise.
Okay.
And we can use that to help the engine get faster.
Okay, cool. Okay, so in this session, we're going to learn about some of the platform improvements. I know there's some new stuff from Intel, so let's get right into it.
So we're here to talk today about some of the data platform improvements that we have in SQL Server 2022. One of the main ones that we have is this new concept that we call hardware offloading. So you're taking instead of running the compute on your cores for SQL Server, you offload it to a device, and then you get to run SQL Server on fewer cores. And given the cost of licensing, this can be very beneficial, particularly if you like to run your servers hot. So when we think about hardware acceleration for backup compression, why do we compress backups? We're going to look to reduce the capacity, right? So how much storage space they're taking up. But we also want to improve the performance. And there's less bits traveling over the wire. And as a result, we get faster backups, faster restores. There are out there already some existing backup compression products. In case you're wondering why did we get into this space, given that there are existing products out there. One is that they're all software based, so that's overhead on your CPUs. The other is that the backup speed is highly variable depending on your workload, and it's more likely to have an impact on your workload. So that's why we looked at this solution that's hardware based for offloading your backup compression. And so these are some of the results. We'll talk about this in more depth at our panel session later. We're seeing some significant speed ups in terms of duration. And we're seeing minor savings in terms of capacity. Okay. I don't know if we have time to go through the demo. So, as you can see, this, it's a T-SQL command to enable this hardware offload, and the accelerator is QAT, that's QuickAssist Technology, but we plan to iteratively add more of these to the product. Each time you make a change, because you can force, as well as hardware mode, we also have this thing called software mode. And it serves as a failback if there's a problem with your driver or with your card or some kind of failure, we have the capability of forcing software mode only. And each time we do any kind of change there, it will require a SQL Server restart. And these are just the libraries from Intel that we load. And you see we take a backup. By default, we continue to use MS Express, which is the existing backup compression algorithm. It's very light on CPU, and that was kind of what it was designed for. So if you just say compression, that's what it will use. You have to explicitly specify QAT deflate if you want to use that algorithm. You can also still specify the default if you just want to be, for whatever reason, maybe for clarity. And what we're going to do here is generate some CPU load on the system. One of the things is that the software-based algorithm actually outperforms the hardware offload if there's no pressure on the CPU, because it scales linearly with the amount of CPU that you have. And we're running this box, as you can see, we're running it hot. Because you only require fewer cores in a situation where you are doing hardware offloading, it shortens the time immensely compared to trying to take a compressed backup while your CPU is under load. And as you can see here, we're specifying our QAT deflate. And one of the things, if you take away anything from this session, if you are going to implement this new algorithm, stripe your backup files. 8 seems to be a good number, but it will vary from environment to environment. But really, big main takeaway is to stripe your backup files across multiple files. So we can see quite clearly the improvement. So basically, if there's no CPU load, software-based will outperform. If there is heavy CPU load, hardware-based will outperform. It makes sense. We're offloading in this case. We're offloading to what's called an 8970. It's a PCIe card. And that's doing the actual work. So far fewer cores are required by SQL Server. Okay. Now, so this is a very strange in the hardware world. We have if anybody's heard of HCI, so hyper-converged infrastructure, we have that taking a prominent role. At the same time, we have customers that want to scale out their storage independently and completely disaggregate their servers. They want to have independent memory, independent compute, independent storage, and that they can centrally manage. And one of the ways to do this is a new fabric that's called CXL, or Compute Express Link. And this is something that we'll see in future years to come. The servers that people will be buying, I don't know if anyone wants to go over to the AWS stand over there, but they have a 2U server that looks very different. It's going to look very different than the servers that you buy in 2024 or 2025. There's going to be a lot of changes. Okay, so let's talk about the SQL servers in memory family. So with Intel, who are the main market for persistent memory, have decided to discontinue the product. So this sets things back a little bit. We do get a lot of questions as to whether we then are going to discontinue this from our product, and the answer is no. We think that there will be rival technologies that will eventually emerge. There are already NVMe devices on the market that are byte addressable. It's a gap that will be filled. So in memory OLTP or Hackathon, one of the things that we did with 2022 is we got more aggressive about cleanup, and we also gave you the power to manually clean up some of the system buffers and things like that. We have our memory optimized TempDB metadata. We have finally hackathonized, for want of a better word, the last of the system tables in TempDB. And we cannot find, I think Bob has run as a challenge, we cannot find anyone who could generate contention in TempDB now, even for single file scenarios. So hugely impressive work there. Memory protection keys, this again is, I'll talk a little bit about enlightenment, and that ties in with memory protection keys. If your storage is also your memory, you want to make sure that any corruption that happens to memory doesn't make it to storage. This is one of the ways we do it. We didn't do any particular work on this in 2022, but tail log caching, or the official name is persisted log buffer, but somehow it became known as tail of log caching. It's on Windows and Linux. The other thing that one of the main feedbacks we got in SQL 2019 when we launched, we had this feature called enlightenment. And enlightenment allows you to, in user space, perform I/O and bypass the kernel. And SQL likes to run in user space. And this is extremely fast, extremely lightweight. It lowers the CPU and it increases the performance of the server. So when we initially brought it out, we brought it out only for Linux. So what we heard, the feedback we heard continually was, why is this not on Windows? So I'm proud to say that on Windows 2022, you now have enlightenment. So for anyone who's looking at this but kind of said, oh, I can't do it because it's Linux, maybe take a look at it again. And then our main feature is hybrid buffer pool, which is a very unique feature where Instead of your buffer pool being tied to a NUMA node, your buffer pool is tied to files that you place on persistent memory. So your persistent memory becomes both your storage. Don't worry, it took me a while to get this to. Your persistent memory becomes both your storage and your buffer pool at the same time. So it's a way to extend the page life expectancy, reduce buffer pool trashing. Perhaps you have a huge index that gets scanned. You could put that into hybrid buffer pool, and far less likely to have trashing of your buffer pool. We did do some tweaks in 2019. We added read caching, some of the hotter pages, index root pages, that kind of thing. We put into DRAM because DRAM is still faster than persistent memory. And then what we did in 2022 is a feature called direct write. So one of the big drawbacks of hybrid buffer pool is that it was read-only. So again, we've hit this before, buffer pool extensions, read-only. So hybrid buffer pool was read-only. Now, we have figured out a way to make it direct write. So we can make a mem copy from, it'll be easier on this slide. Okay, so first off, I'll just talk. You can use this as a block device, just regular block device with nanosecond latency. It will probably improve your workload. Then we have this persistent log buffer, and see that log cache? That's only 20 megabytes in size. Very, very small. So 20 megabytes in size per database. And if you use this, coupled with hybrid buffer pool, you can do a mem copy from the durable log cache to the buffer pool without having to copy it back into RAM and wait for the lazy writer or some kind of checkpoint process to write it back down to disk. As a consequence, once again, SQL can run longer in user space, and we see less CPU, we see less kernel switching, and we see quite a few improvements there. The Enlightened I/O, as I mentioned, this is a way to essentially bypass the kernel I/O. We memory map the files, and we write to the memory map in user space. But what we don't allow you to do it for is log files, because we still have some cases where there's an expectation of sector atomicity, and what that means is basically the smallest write unit, so either 4K or 512 bytes, depending how you format it. There's an expectation that will be the smallest I/O it ever sees. So as a consequence, if you put your LEF file on PMEM, it will work. It just won't do the Enlightened I/O. All right. Final one. This is AVX 512, which is very exciting if you're in the analytics space. It's a form of parallelism, essentially, a single instruction, multiple data. And there's been, over the years, various different implementations of AVX 512. And so we're specifically kind of have been looking at Ice Lake, but AVX 512 is available for AMD Genoa, and it's available in other processor architectures as well. And a lot depends on the microarchitecture of the CPU you're using as to the benefit that you will get from it. So it's very much something you need to test yourself and see if you get the benefits. For that reason, for 2022, we have put it behind a trace flag, but we have documented that trace flag to allow people to test. I don't know if it comes up here. And we use it in one place only, which is read-only batch mode Columnstore. That's the only place we use it. It's very wide, it's 512 bytes. As you can imagine, we get a lot of work done. So that's the only place we use it currently today, but we are looking at other use cases. I'll go briefly through this because I know I'm taking up a lot of time here, but we have some Columnstore improvements. One of probably the major ones, if you work with Columnstore, is that we do ordered Columnstore now, which is a huge improvement. We're also able to do segment elimination on a number of types that, I would argue that probably aren't the best to be in a Columnstore table, but it is what it is. But it will skip like GUIDs, daytime offsets. It will do segment elimination. And it's not necessarily, much like partition elimination, it's not necessarily a huge performance feature. It can improve performance, but I wouldn't view it or have a takeaway that it's a performance feature. All right. Do you want me to skip through this on him? Okay. This is just to show, right? So basically, this is to show we're running an extended event, and we're showing what's available in terms of vector extensions and what we're using. So we're using AVX2, even though AVX 512 is available, because we haven't enabled our trace flag. And once we go ahead and enable our trace flag, which is not a startup trace flag, which is always nice, we can go back now, run the same workload, and we will see it take advantage of AVX 512. So it's not about the speed, even though it's like 100 million rows or so. It's more just to show that we do take advantage of these vector extensions in the latest processors. So when you're looking at upgrades, and I know it can be tough, but when you're looking at upgrades, do consider upgrading the hardware as well as the software.
Thanks, Brian. That was a great session. I learned so much. For our viewers online, I bet you learned a lot as well. If you like this episode, go ahead, give it a like, leave us a comment, let us know what you think. Put some links in the description for you to learn more, and we hope to see you next time on Data Exposed.